Hello everyone. Good evening. Good evening everyone and welcome to the class. So today is marathon class for control system. So let's start the session. So it is about me. I am Vijay Bansal, 20 plus years of teaching experience and 6 times gate ranker, 4 times in electrical and 2 times in electronics. Yes, good evening. Good evening everyone. So first question. Consider the block diagram representation of the system shown in the following figure. In the given figure, we have to calculate the value of C by R, means transfer function. What is the value of C by R? We have to calculate. So, in this block diagram, using the block reduction method, we have to calculate C by R. C is the output and R is the input. So, what is the overall transfer function if the gain is shown in the block? So if I give you the solution, if you reduce this block diagram into the simpler one, you can easily solve. So there is a feedback from the C point, and at this point there is a feedback of 4, and here is also feedback of 4, because if it is C, C times 4 is the 4C, and it is also 4C. Means if it is C signal, it is the 4C, and at the block diagram, at the takeoff point, signal remains same. So it is 4C, it is also 4C. So if I solve and simplify this block diagram, I can easily solve this question. And the solution of this question is, it is the R input. This gain is 9. Good evening, Ashok. Good evening. Very good evening. So if I reduce this block diagram, I have the diagram like this. And if you reduce this diagram like this, you can easily solve the transfer function. So it is 4. And this is also 4, because this 4C is here, the feedback is 4C. Thank you, Ashok. Thank you, and same to you, Bache. Same to you. So it is like this. 4 1 ja 4. So if you reduce this diagram like this, C by R can be easily calculated. What is the total C by R? You can give the answer in the chat box. So complete answer is, if you reduce the upper block diagram using the G upon G 1 plus GSHS, it can be simplified as 2 upon 1 plus 4 into 2, G upon 1 plus GH. So if you reduce this diagram, the overall gain of the shaded portion is 2 upon 1 plus 4 multiplied by 2. So it is 2 upon 8 plus 1, 9. 2 upon 9 is the answer. So again, if I reduce further reduction, it is like this. It is R. This block is 9. And this overall gain of this block is 2 by 9. 2 by 9 and feedback is 4. It is C. So there is the only important one is that there is a two feedback from the C. One is at this summing point and one is another summing point. And both summing points are the gain is 4C. So from the C point, there is a two feedback. One is -4 and other one is also -4. So I get the answer 9 multiplied by 2 by 9 is the 2. So overall gain of these two blocks are in cascade. So overall gain is 2, 9 multiplied by 2 by 9, that is the 2. And if it is 2, it is H is 4. So complete transfer function C by R is equal to 2 upon 1 plus 2 multiplied by 4. So correct answer is 2 upon 1 plus 8. So 2 by 9. And 2 by 9 is 0.22. So C by R of this question is 0.22. Correct answer of this question is 2 by 9 or 0.2. Because in the NAT question, you cannot give the answer in fraction. You have to give the answer in decimal form. So 0.22 is the correct answer of this question. Although 2 by 9 is also correct, but while giving the answer in the GATE exam, you have to give the answer in fraction, decimal fraction, not the 2 by 9. Okay, moving to the next question. Give the answer of this question. For the control system shown below, the value of beta, you have to calculate the value of beta to make the damping ratio zeta of the system equal to 0.5. What should be the value of beta so that the damping ratio of the overall system is 0.5? So easy question. First of all, reduce the block diagram and make the characteristic equation. And after making the characteristic equation, zeta is calculated in terms of beta and put the zeta as 0.5 and you can calculate the beta. So procedure is good evening Tarun, very good evening bache. So this question has two parts. One is the reduction, block diagram reduction, and second one is to calculate the beta uh, if the zeta is given as 0.5. So I am solving this question. It is GS, it is HS. So if you reduce this diagram, GS upon 1 plus GSHS, if you reduce this block because it is a negative feedback, and if you solve GS upon 1 plus GSHS, so transfer function is 5 upon S, S plus 2 divided by GS upon 1 plus GSHS. So 5 upon S into S plus 2 upon 1 plus 5 upon S into S plus 2 multiplied by beta S because SS is beta S. And if I further simplify, I get 5 upon S into S plus 2 after taking the LCM cancelled out. So 5 upon S, S plus 2 plus 5 beta S. 5 beta S. So it is 5 upon S into S plus 2 plus 5 beta S. So we get 5 upon S square plus 2S plus 5 beta S. So it is S times 2 plus 5 beta. This is the overall this block diagram reduction. And what is the correct closed loop characteristic equation? Closed loop characteristic equation is Ashok is giving the answer. I think Ashok bache little bit mistake is there. So I am solving. So closed loop characteristic equation. Closed loop characteristic equation is 1 plus GSHS is 0. And 5 multiplied by 2 is 10. So closed loop characteristic equation is 1 plus 2 multiplied by 5 upon S square plus S times 2 plus 5 beta is equal to 0. So closed loop characteristic equation becomes S square plus 5 beta plus 2 times s plus 10 is equal to 0. So if you compare it with the standard characteristic equation, what is the standard characteristic equation? Standard characteristic equation is s square plus 2 zeta omega ns plus omega n square is 0. So omega n square is 10, implies omega n is equal to root 10 radian per second. The value of omega n is root 10 per radian per second. And once you calculate the omega n natural frequency, now S coefficient, if you compare 2 zeta omega n is 5 beta plus 2 and zeta is given as 0.5. Zeta is given as 0.5 and omega n we have already calculated, that is the root 10. If you put the value, yes, now Ashok, your answer is correct now, bache. Your answer is correct now, Ashok. So it is 2 times zeta is 0.5 into omega n into root 10 is equal to 5 beta plus 2. So it is root 10 is equal to 5 beta plus 2. So beta is equal to root 10 minus 2 divided by 5. Using the calculator you can solve and it comes out, because Ashok have already calculated, so it comes out 0.232. So beta, correct answer of the beta is up to the 3 decimal point is 0.232 and virtual calculator is available in the gate, so you can easily give the answer beta as 0.232. I hope it is clear to everyone. Now moving to the next question. Third question. I have taken lot of questions today. So the asymptotic Bode magnitude plot of open loop transfer function of a unity negative feedback system is shown in figure. If the input is unit parabolic, e square by 2 ut, so then the steady state error. You have to calculate the steady state error. And it is very easy. You have to calculate the steady state error if the input is given. And input is given as unit parabolic. So as you know, if the input is given as unit step, steady state error is 1 upon 1 plus kp. If the input is unit ramp, steady state error is 1 by kv. And if the input is unit parabolic, steady state error is 1 by k. So ultimate you have to calculate the k, acceleration error coefficient. So in this question, okay, Ashok is saying, sir, this topic very difficult for me. Okay. Ashok, I am explaining little bit. Listen, my dear. So Bode plot is given and input is also given. So Ashok, you should note, bache, if input is unit parabolic, input is equal to t square by 2 ut. So input decide which formula you have to apply for the steady state error. So for unit parabolic input, steady state error is 1 by Ka. 1 by K. And K is acceleration error coefficient. K is acceleration error coefficient. And using the Bode plot, if the initial slope is minus 40 dB per decade, guaranteed it is type 2 system. You can say directly it is type 2 system because starting slope decides the type of the system. So if the starting slope of the Bode plot is minus 40 dB per decade, it means it is type 2 system. Type 2 system. And if it is type 2 system and only two pole at origin, otherwise there is no other zero and pole. Why? Because there is no slope change. And if there is no slope change of the Bode plot, that means only two pole occurs at the origin. So open loop transfer function Gf of unity feedback is k by s square. K by s square. And what is the k? Acceleration error coefficient is limit s tending to 0 s square gshs. Hs is unity. So you apply this formula and k is equal to k. Acceleration error coefficient is nothing but it is the k. So you have to calculate the only k. You have to calculate the only k. And k can be easily calculated using the starting gain line. K of the Bode plot, using the Bode plot, K can be easily calculated using the starting slope line. And what is the starting slope line? Gain of the starting slope line, gain of starting slope line, you should remember this formula. Starting gain is equal to, starting gain is equal to 20 log K minus 20 n log omega. This is the formula. Starting gain is equal to 20 log K minus 20 n log omega. This formula is valid for starting slope line. So what is the starting gain given? Starting gain is given 20 dB, type is type 2 and starting frequency is 0.1. If you put the values, you can calculate the value of f. Easily you can calculate the value of k. So what is the starting gain? Starting gain is given as 20. If I solve, starting gain I can put it is 20 is equal to 20 log k. I have to calculate the value of k minus 20 n. N is the type of the system and it is type 2. So n is equal to 2 log omega. Omega is the starting frequency. That is 0.1. Now you can solve and calculate the k. So what is answer? 20 is equal to 20 log k minus 20 to the 40. And log 0.1 on base 10 is minus 1. It is a simple calculation because it is on base 10. So log 0.1 on base 10 is minus 1. So it becomes 20 is equal to 20 log k plus 40. Minus 40 multiplied by minus 1, that is the plus 40. So we can say 20 log k is equal to minus 20. Log k is equal to minus 1. Or k is equal to 10 की power minus 1, that is the 1 by 10. Antilog, you can calculate the antilog using the calculator as well. If you are not able to solve manually, you can solve using the calculator. So k is equal to 1 by 10. And once you calculate the k is as 1 by 10, acceleration error coefficient k we have already calculated as k. So it is the 1 by 10. And once you calculate the k, steady state error for a unit parabolic input is 1 by k. So it is Prasanjit is saying, sir, in other cases, what we need to do, sir. Okay, bache, I am telling. Ashok, k value is 1 by 10, that is 0.1, and 1 by k, 1 upon 1 by 10, that is the 10. So steady state error is 10. Steady state error is 10. So correct answer of this question is 10. Now Prasanjit is asking, sir, in other cases, what we have to do? So this is a very, very valid question. And I am explaining for the Prasanjit. Tarun is saying, sir, in the type 2, direct k is equal to omega slope touching the log. No, no, no. Tarun, but for the type 2 system, starting slope line intersect at root k. Omega is equal to root k, not k. Because it is the omega is equal to k for type 1 system. For the type 2 system, omega is equal to root k. Root k. So Tarun, for the type 2 system, starting slope line intersect the 0 dB axis at omega is equal to root k radian per second. And for the type 1, it intersect omega is equal to k. So Tarun, you have written for type 1 system. Your answer for type 1 system is correct, but for type 2 system, correct answer is omega is equal to root k. So either you, yes, Tarun have given the another possibility to solve this question by calculating this intersection point. by using the slope. Slope is equal to y2 minus y1 upon x2 minus x1. So you can calculate the omega 2 as well. And omega 2 is nothing but it is the root k. So either using this formula you can calculate omega 2 and omega 2 comparing under root k. Now you can calculate the k as well. And Prasanjit is asking, sir, if what are the other methods to solve the k? K can be solved using either this point or at this point where the frequency is given. Where the frequency of starting slope line is given, you can apply this formula anywhere. You can use this formula anywhere in the starting slope of the line. This formula is valid anywhere for the starting slope line. Not valid for start as well as not only valid at the starting point but as well as valid for any point of the starting slope. Means this formula can you apply at this point also if frequency is given. If the frequency is given at this point and gain at this frequency is 0 dB, you can apply this formula at here also. But in this case, the omega is not given. Omega is not given, so you have to apply here or here. Where the frequency is given for the starting slope, you can apply. Or Prasanjit Bache, if you have the difficulty for finding the K using the Bode plot, I will take the lecture, theoretical lecture or any other questions of the Bode plot. Because I have taken lots of Bode plot questions today itself. Okay, moving to the next question. It is again very good question. The root locus diagram of a unity negative feedback control system with loop transfer function as GF is equal to K upon S plus 2 is intersecting the line zeta is equal to 0.5. What is which is shown in the figure? The value of K at intersection you have to calculate. Means one is the zeta line and one is the root locus. So where uh, zeta line intersect the root locus, you have to calculate the K at that intersection point. So one is the root locus and one is the zeta line. Where zeta line intersects the root locus, what is the K at the point of intersection? So easy question, not a tough question. So I am solving this question. It is a star rated question. According to me, it is a star rated question because you must know the root locus as well as the time response. Second order time response, if you know the concept of zeta line and zeta is equal to cos theta. If you apply this like this, you can solve this question very easily. So I am solving this question and according to me, this question is a star rated question. So first of all, concentrate of the root locus flow. So what is the root locus? GFSS. SS is unity and it is given as K upon S plus 2. K upon S into S plus 2. So what are the open loop poles? Open loop poles are at K is equal to 0. One pole is at origin and K is equal to 0. One pole is at minus 2. Closed loop pole at K is equal to 0 are at origin at S minus 2. And it is a sigma, it is j omega because it is a S plane. Root locus float is always drawn on the S plane. If I put K is equal to 1, so it becomes a perfect square because closed loop characteristic equation is 1 plus K upon S plus 2 is equal to 0. And if I put K is equal to 1, it becomes S plus 1 ka whole square. So at K is equal to 1, both the pole occurs at minus 1. Means one of the root locus lie here. I am using this color pen. And one of the root locus line intersect this. And K is equal to 1. Both the root locus intersect and after they become separated like this. One goes here and one is like this. Root locus you can draw very easily. Everyone knows how the root locus can be plotted. I am just giving the idea. It is the root locus float. K is equal to infinity and it is also K is equal to infinity. because there is no zero, open loop zero. So both are root locus branches आपका terminate at infinity. So it is the root locus branch. Now the root locus and the zeta line intersect the point at this. So we have to calculate the k value here. What is the k at this intersection point? So first we calculate and this value is -1. This value is -1. Yes, -1 is the centroid. Very good, bache, very good. -1 is the centroid, Tarun, as well as -1 is the breakaway point as well. In this question, -1 is the centroid as well as -1 is the breakaway point. So this intersection point we have to calculate. This intersection point we have calculated and zeta is equal to 0.5. And if zeta is equal to 0.5, so cos theta is equal to zeta. Cos theta is equal to zeta, so theta is equal to cos inverse zeta. And cos inverse 0.5. Cos inverse 0.5 is 60 degree. So this angle is 60 degree. And if this angle is 60 degree, base is 1, so we can calculate the perpendicular. Tan theta is equal to perpendicular upon base. Theta is equal to 60 degree. Tan 60, yes, very good. Theta is equal to 60, so tan 60 degree is equal to perpendicular upon base. Base is 1 because we have only take consideration the magnitude. So what is the perpendicular? Perpendicular is equal to value of the perpendicular is tan 60. Tan 60 is root 3. So correct answer, perpendicular is equal to tan 60. And tan 60 is root 3. Now this question can be solved very easily. So this intersection point is, because perpendicular is root 3, this perpendicular is root 3 and base is 1. So this point is -1 plus j root 3. This intersection point is -1 plus j root 3. This intersection point is -1 plus j root 3. I am writing here. This intersection point is -1 plus j root 3. And if this point lie on the root locus, we have to calculate the k. Now we can apply the magnitude criteria. Once we know the intersection point, value of s at the intersection point, now apply the magnitude criteria, we can calculate the k. So apply magnitude criteria now. Apply magnitude criteria. And if I apply the magnitude criteria, I get modulus of GSHS at S is equal to -1 plus j root 3 is equal to 1. Now question become very easy. K upon S plus 2 modulus at S is equal to -1 plus j root 3 must be equal to 1. So put S is equal to -1 plus j3 here. So it is the modulus of K upon S -1 plus j root 3 and K plus 2. In the K plus S plus 2, in the S plus 2, if I put S is equal to -1 plus j root 3, it is 1 plus j root 3. Modulus is equal to 1. K is positive real, so K is K upon -1 plus j root 3 modulus is 2. 1 plus j3 modulus is 2 is equal to 1. So value of K is equal to 4. This question is little bit lengthy, but a very good question. K is equal to 4. So K is equal to coming bache 4 because modulus of -1 plus j root 3 is 2, not 4. Because under root, modulus of -1 plus j root 3 modulus is 2, not 4. Because it is under root -1 का square plus root 3 का square. -1 square is 1, root 3 square is 3. So under root 4. Under root 4 is 2. Yes. So correct answer is value of the k is 4. Correct answer of this question is value of k is equal to 4. So I am once again giving the steps how we can calculate it. It is asking that where the root locus branch intersect the theta is equal to 0.5 line, what is the k value at that intersection point? So initially we have calculated the intersection point. And intersection point we have calculated using the geometry. First we draw the root locus, and this root locus branch intersect at the zeta is equal to zero point 0.5 line, 0.5 line at -1 plus j root 3. And once we calculate the intersection point, now apply the magnitude criteria to calculate the value of k. This type of question is very important in the gate exam because they are the secondary questions. You cannot calculate the k value directly. First of all, you have to calculate the intersection point. Without intersection point, you cannot calculate the value of k. So these type of questions are very important in the gate because below average student cannot solve these type of questions. Above average student only can solve these type of questions. And in this question, root locus knowledge as well as time response knowledge both are required for this question. Okay. Now moving to the next question. Try to give the answer of this question. The unit step response of a particular control system is given as Ct is equal to 1 minus e to the power minus 5t ut. The transfer function of the system is. So unit step response of a control system is given as 1 minus 5 e to the power minus t ut. So what is the transfer function of the system? Yes, yes. Previous question was the good question. बच्चे बिल्कुल सही सरवन. Very good. This question is easy, but student might commit mistake in this question. So I have taken this type of question because most of the student knows d by dt step response differentiation is the impulse response. So students generally differentiate this and they use the differentiation. One differentiation is zero. But the differentiation of 1 is not a 0, it is the del t. So student might mistake. Yes, yes. Prasanjit is giving the answer. Little bit mistake is there. Okay, Prasanjit, I am giving the answer. I am giving the answer. So step response, step response Ct is 1 minus 5 e की power minus t ut. So what is the CS? CS is equal to 1 by s, ut Laplace is 1 by s minus 5 e की power minus t ut Laplace is 5 upon s plus 1. So if I take the LCM, s into s plus 1, if I take the LCM, I get s plus 1 minus 5s. So CS, step response in S domain, I get 1 minus 4s upon s plus 1. This. And once we have the CS can be written as TS into RS. And TS is nothing but it is the transfer function or impulse response. So TS into RS. CS we have calculated 1 minus 4s upon s plus 1 is equal to TS. We have to calculate the TS into RS. RS is 1 by s. S has cancelled out both sides. So what is the TS? TS is 1 minus 4s upon s plus 1. This is the correct answer. This is the correct answer. 1 minus 4s upon s plus 1. 1 minus 4s upon s plus 1, that is the option C. 1 minus 4s upon s plus 1, option C is correct answer. Some student might commit mistake in this question using this formula. Transfer function is equal to impulse response is equal to d by dt of step response. Step response. So if you use this formula, so differentiation of 1 is not 0, differentiation of ut is the del t. So if you use this formula, it is like this: d by dt of 1 minus 5 e की power minus t ut. So before differentiating, you should write like this: d by dt is ut minus 5 e की power minus t ut. And if you differentiate, you get like this. If you differentiate, you can get the answer. Ut differentiation is del t. Del t plus 5 upon 5 e की power minus t ut. Or differentiation will give the wrong answer. Because at t is equal to 0, it is not 0. So that is why this answer will give you the wrong answer. So don't use this method in this type of formula. You use this method because S domain is the error free. If you solve the transfer function in S domain, it is a error free answer. Error free answer. Okay. Now moving to the next question. It is so simple. It is easy question. The magnitude and the phase of the frequency response of a system with transfer function Gs is equal to e की power minus TDS upon S at the frequency omega is equal to pi by 2d. This is written like this. I am writing correctly. Gs is equal to e की power minus upon S like this. It is written like this. P suffix d into S. Tau. Tau d S divided by S. So if the transfer function is given, open loop transfer function is given, we have to calculate modulus of Gs or modulus of Gj omega at omega is equal to pi by 2 tau d, and we have to calculate angle of Gj omega. Magnitude and phase we have to calculate at a particular frequency. So it is so easy. Neither gain margin nor phase margin is asked. Only asked is what is the magnitude and what is the phase of this particular transfer function at this particular frequency. So it is so easy. So transfer function is given as transfer function. If I solve this question, transfer function of the system is given as e to the power minus tau d into S upon S. So for frequency response, put S is equal to j omega. For frequency response, put S is equal to j omega. And if you put S is equal to j omega, what you get? You get g j omega is equal to e की power minus j omega tau d divided by j omega. So first we have calculate the magnitude and then the frequency, phase angle. So if I calculate the modulus, what I get? Modulus of g j omega is equal to modulus of e की power minus j omega tau d divided by j omega. E की power minus j theta modulus is 1. Everyone knows e की power minus j theta modulus is 1 because e की power minus j theta can be written as cos theta minus j sin theta and modulus is 1 upon omega. 1 upon omega. So what I get? G j omega modulus at omega is equal to frequency is pi by 2d. Pi by 2 tau d. So what I get? 1 upon omega. Omega can be written as pi upon 2 tau d. So correct answer is 2 tau d divided by pi. That is the magnitude. That is the magnitude of this transfer function at this particular frequency. Once you calculate the magnitude, now what is the phase angle? If I calculate the phase angle, what is the phase angle? Phase g j omega is e की power minus j omega tau d divided by j omega. So what is the angle of G j omega? Angle of G j omega is equal to minus omega tau d minus 90 degree. J omega angle is 90 and I am writing in radian. Because omega is given in radian, so instead of writing 90, I am writing in radian. And if I calculate angle at this particular frequency, omega is equal to pi by 2 tau d. Angle at angle of G j omega at omega is equal to pi upon 2 tau d is equal to minus omega multiplied minus omega. Omega can be written as pi by tau to 2 tau d minus pi upon 2 tau d multiplied by tau d minus pi by 2. Tau d cancelled out. So it would be minus pi by 2 minus pi by 2. So correct answer is minus pi or minus 180. So correct answer of this question is 2 tau d upon pi is the magnitude and minus 180 degree is the angle. Because angle is not given in radian, it is given in degree. So correct answer is B. B is the correct answer. 2 tau d upon pi and angle is minus 180. Because it is minus pi radian, minus pi radian in degree can be written as minus 180 degree. So correct answer of this question is option B. Option B is the correct answer because three magnitudes are matching, so we have to calculate the phase angle as well. Phase angle as well. I hope it is clear because this question is so simple. Uh, Open loop transfer function or transfer function is given, and we have to calculate the magnitude and phase at this particular frequency. Okay, Tarun is asking, sir, please angle एक बार और बता दीजिए. Okay बच्चे, okay Tarun. It is so easy. देखिएगा बच्चे, angle we have to calculate. So angle of this is equal to angle of this divided by angle of this. So I am writing here one more line. Angle of G j omega is equal to angle of e की power minus j omega tau d upon angle of j omega. So this angle of j omega is 90, no doubt here. Because a pure imaginary quantity in positive have the angle 90 degree. So either plus 90 or plus pi by 2, whatever you write. And angle of this, e की power minus j theta. If you compare it with, if you compare e की power minus j omega tau d with e की power minus j theta. So what is the angle? Angle is this. So you can compare the angle with theta like this. So theta is equal to nothing but omega tau d. I hope it is clear. Because if expression is written like this, e की power minus j something, you can directly compare e की power minus j theta. And angle of e की power minus j theta is minus theta. I hope everyone it is clear. So angle of e की power minus j theta is minus theta. So e की power minus j omega tau d angle is minus omega tau d. But this angle is in radian because omega is always in radian. So this angle is in radian. So to convert into the degree, either we have to multiply by 180 by pi or calculate the angle in radian. So first of all, I have calculated angle in radian and then convert into the degree. Okay, Tarun, now moving to the next question. This question is so simple for the signal flow graph. Everyone can give the answer of this question. For the signal flow graph shown in the figure below, the transfer function gain x5 upon x1 will be. This is the input node, this is the output node, x5. So we have to calculate the gain or transfer function or transmittance. This is also called overall transmittance x5 by x1. Using the Mason gain formula, we can calculate easily. So there are two forward paths. One is this forward path and second one is this forward path. Using the two forward path, we can calculate the overall gain. X5 upon X1 is P1 del 1 plus P2 del 2 divided by del. It is the Mason gain formula. I am using the Mason gain formula to calculate this question. Mason gain formula. So what is the P1? If I calculate this forward path is the first path, 1 multiplied by 2 multiplied by 3 multiplied by 4. So P1, first forward path gain is 1. First forward path gain P1 is 1 multiplied by 2 multiplied by 3 multiplied by 4. 2 3 ja 6, 6 4 ja 24. Second forward path gain P2. P2 is equal to 1 multiplied by 4, 5 multiplied by 4. 1 multiplied by 5 multiplied by 4, that is the 20. This is 24, this is 20. Now if I calculate the del, what is the value of del? There are two loops. One loop is this and second loop is this. So L1, first loop gain, L1 is 3 multiplied by 4 multiplied by minus 3. 3 4 ja 12, 12 3 ja 36. Minus 36. And what is the L2? L2 is 5. Second loop gain is 5. And both are touching to each other. Both loop are touching to each other. So what is the del? Del is equal to 1 minus L1 plus L2. Because plus L1 L2 is 0. Because both the loops are touching, so L1 L2 is 0. So correct answer of del is 1 minus L1. L1 is minus 36 and L2. L2 is 5. So it comes out 1 minus 31. So it is 32. Now the formula del 1. Del 1 is 1 because both the loops are touching to first forward path as well as second forward path. And if both the loops are touching to first forward path as well as second forward path, so del 1 is 1, del 2 is 1. Because both the loops are touching to their corresponding forward path. So what is the answer? X5 upon X1, if I calculate, is P1. P1 is nothing but we have calculated 24 multiplied by 1 plus P2. P2 is 20 multiplied by 1 upon del. Del is 32. So correct answer is 24 plus 20 divided by 32. 44 divided by 32. So x5 upon x1 is equal to 11 by 8. And 11 by 8 is 1.375. 11 by 8 is 1.375. So correct answer is bache 1.375. You can check. It is so easy. This question is not so much tough. 11 by 8 is the correct answer. Yes, 1.375 or 1.3 is the correct answer. Very good, very good. 1.375 is the correct answer of this question. Okay. Yes, yes, Ashok, very good, bache. Now your answer is absolutely correct. Okay, moving to the next question. The characteristic equation of a unity negative feedback control system is given by. Yes, Tarun, bache, bilkul sahi. So the intersection of the asymptotes of the root locus. Intersection of the asymptotes is centroid. Intersection of asymptote is called centroid. So in this question, indirectly it is asking the centroid. And centroid is at the negative or real axis. The imaginary part is 0, so we have to write the real part of the S, because imaginary part is always 0 for the centroid. Easy. If you make the characteristic equation. So it is s square plus s cube plus 3s square plus 2s plus ks plus k is equal to 0. So what I get? To make the open loop transfer function using the characteristic equation, and once you calculate the open loop transfer function, you can calculate the centroid as well. So important point is you have to calculate the open loop transfer function using the characteristic equation. So I am solving s cube plus 3s square plus 2s plus ks plus k. If I take the k common, s plus 1 is equal to 0. And this equation can be, it is a characteristic equation. It is a characteristic equation. So it can be written as s cube plus 3s square plus 2s common. So this equation can be written as 1 plus k s plus 1 upon s cube plus 3s square plus 2s is equal to 0. Or this equation can be written as 1 plus k s plus 1 upon, if you take the s common, s square plus 3s plus 2 is equal to 0. If you compare it with closed loop characteristic equation, if you compare it with GSHS, HS is 1, unity feedback system is there. So it is, if you compare it with 1 plus GS is equal to 0. So open loop transfer function GS is, open loop transfer function GS is equal to K times S plus 1 upon S into S square plus 3S plus 2 is equal to 0. If you factorize the denominator further, you get K S plus 1 upon S, and factor of S square plus 3S plus 2 is S plus 1, S plus 2. S plus 1, S plus 1 cancelled out. So open loop transfer function GS can be written as K upon S, S plus 2 is equal to 0. Now you can calculate the centroid very easy. What is the formula for centroid? Centroid is summation of poles minus summation of zeros upon P minus Z. Summation of poles is one pole is at origin, one pole is at minus 2. There is no zero, so summation of 0 is 0 upon P minus Z. Number of open loop poles are 2, number of open loop zeros are 0. So correct answer is minus 2 upon 2. So centroid is coming minus 1. So correct answer of this question is minus 1. Because actually value of s comes out minus 1 plus j0. But imaginary part is 0, so we have to write minus 1. Very good, Tarun, very good. Your answer is absolutely correct. So intersection of asymptotes of the root locus is s is equal to minus. Correct answer of this question is minus. Very good, Ashok. बिल्कुल सही है बच्चे. Correct answer, Ashok. Very good. So centroid is equal to minus 1. Minus 1 is the centroid. And this question we have already done. Some student might say, sir, it is the root locus we have already done. Because the root locus of k upon ss plus 2 we have already done. This pole is at minus 2, this pole is at 0, at k is equal to 0. And at minus 1, there is a centroid. At minus 1, there is a centroid, and one of the asymptotic line at 90 degree, and second one of the asymptotic lines is 270 degree. I hope everyone is clear, because this root locus we have already done. This type of root locus we have already done. So centroid is, and in this question, it is a special question. So centroid and breakaway point both are at minus 1. Both are at minus 1, centroid as well as the breakaway point. Centroid and breakaway point may be differ, but in this question, they are similar. Okay, try to give the answer of this question. The open loop transfer function of a unity negative feedback is given as Gs is equal to 100 upon S plus 10 का whole square. So you have to calculate the phase crossover frequency. So easy. This question is simply 1 mark question. According to me, this is a 1 mark question in the case because omega p is directly you have to calculate. And there is a double pole. Only the point is there is a double pole at minus 10. So what is the phase crossover frequency? You can easily calculate. So try to give the answer. So you must know at the phase crossover frequency, phase angle is minus 180. If you know at phase crossover frequency, at phase crossover frequency, yes, Tarun, very good, bache, so fast. Lightning speed. Tarun have given the answer very easy. So at phase crossover frequency, omega is equal to omega p, angle of g j omega h j omega, and omega is equal to omega p must be equal to minus 180. If you use this formula, you can give the answer or odd multiple of 180. You can write the odd multiple of 180. Odd multiple of 180 plus minus 180. Either you write plus 180 or plus minus 180. Both are correct. Both are correct. 180 or odd multiple of plus minus 180. Now you can give the answer. I am solving because it is a unity feedback. Yes. Tarun is saying the direct formula of the root under root is okay, bache. It is also correct. So what is the correct answer? It is GS is given as 100 upon S plus 10 का whole square. So what is the GG omega? GG omega is equal to 100 upon J omega into 10 plus J omega whole square. So what is the angle? Angle of GJ omega is equal to 100 का angle 0 because 100 is a positive real number. So angle is 0. J omega angle is 90. And angle of this 2 times because it is a square, so 2 times angle tan inverse imaginary by real, tan inverse omega by tan. And at omega is equal to omega p, put this angle is equal to minus 180. So at omega is equal to omega p, so minus 90 plus 90 अगर ऊपर ले जाएंगे तो minus 90. So minus 90 minus 2 tan inverse omega p by tan is equal to minus 180. So it is minus 2 tan inverse omega p by tan is equal to minus 90. Minus cancelled out. So tan inverse omega p by tan is equal to 45 degree. So omega p by tan is equal to tan 45. That is 1. And omega p is equal to 10 radian per second. Omega p is equal to 10 radian per second. This is the phase crossover frequency. Phase crossover frequency is 10 radian per second. So correct answer of this question is 10 radian per second. Yes. Prasandeep, your answer is correct, bache. Tarun answer is also correct. And 10 radian per second is the correct answer of this question. Now moving to the next question. A system having transfer function Cs by Rs is equal to 1 upon S square plus 1.5S plus 4 is subjected to a step input having a strength of 2 units. The steady state value of the respective output. This question is application of the final value theorem. This question I have taken to show you the application of the final value theorem. If anywhere steady state value is to be asked, you may consider final value theorem is one of the options. So transfer function is given, input is given. Input is 2 unit of step. Step unit of strength 2 unit. Means input is equal to twice of ut. In this question, input is given as twice of ut input, and transfer function is as well given. So applying the final value theorem, you can calculate the steady state value. So easy. This question is also very easy. So input means Rs. Laplace of input Rs is equal to 2 by S. And Cs is equal to Ts into Rs. Ts is given as transfer function of the system. Ts is Cs by Rs is equal to 1 upon S square plus 1.5 S plus 4. Yes, Prasanjit is giving the answer. Okay, Prasanjit, I think zero point 0.5 is the correct answer of this. Okay, I am solving. I am solving. So what is the CS? CS is equal to ES multiplied by RS. So TS is 1 upon S square plus 1.5S plus 4. Yes, multiplied by RS. RS is the 2 by S. So CS is equal to 2 upon S into S square plus 1.5S plus 4. Before applying the final value theorem, you must assure that pole is not in the right half of the S-plane. And in this question, b square minus 4ac is less than 0 and b is greater than 0. So it is guaranteed that pole lies in the left half of the S-plane. Only one pole exception is one pole lies at the origin. So final value theorem is applicable here. So what is the steady state value? Steady state value. Before applying the final value theorem, you must ensure that whether final value theorem is applicable or not. So output, steady state output C infinity is equal to limit S tending to 0 STS. This is final value theorem. This I am using the final value theorem. But before applying the final value theorem, you must ensure that no pole on the j omega axis except one pole can lie on the origin and no pole in the right half of the S-plane. If any pole lies in the right half of the S-plane or anywhere at the j omega axis except origin, if one pole is at origin, it is acceptable. Otherwise, no pole at the j omega axis anywhere, no pole in the right half of the S-plane, then you may apply the final value theorem. You may apply the final value theorem and the correct answer is 0.5. Very good. So correct answer is limit S tending to 0 SCS, and CS is nothing but it is the 2 upon S square plus 1.5S plus 4. Now it is so easy. And if you put S is equal to 0 in the remaining, it is 2 by 4. That is 1 by 2.5. So 0.5 is the correct answer of this question. So 0.5 is the correct answer of this question. Sir, if the FTV is not applicable, then how can I solve? Okay. Prasanjit, but if final value theorem is not applicable, it means final value is not defined. Suppose that Prasanjit has asked very good question. Suppose that two poles lie here. One is at plus J2, one is at minus J2. So what is the transfer function? Transfer function is 1 upon S square plus 4. What is the inverse Laplace? Inverse Laplace is sine 2t. 1 by 2. 2 multiply, 2 divide. So answer is 1 by 2 sine 2t. So Prasanjit, can you give the final value? No. Because sine function does not have any final value. It oscillates between minus 1 and plus 1. It can never have the final value. So it means final value is not applicable. Second example. If the pole is at right half, minus 1. So what is the transfer function? Transfer function is 1 upon S plus 1. Plus 1. If it is the plus 1, transfer function is x minus 1. And what is the inverse Laplace? Inverse Laplace is e की power t. E की power t means exponentially rise. So at t is equal to infinity, response of the function is infinity. So final value is infinity, not defined. So if final value theorem is not applicable, Prasanjit, it means final value of that function is not defined. Not defined. You cannot calculate the final value, that means. I hope, Prasanjit, you are getting, bache. Either pole lies on the j omega axis, anywhere other than origin, or anywhere on the right half of the S-plane. Final value theorem is not applicable. Okay, Tarun, thank you, bache, thank you. Okay, try to give the answer of this question. The state variable representation of a system is given by the following equation. State model is given x dot t is equal to axt plus but, y is equal to cxt. So ABC matrix is given. If the given system is said to be uncontrollable, the value of A should be. A बताना what is the value of A. It is so easy. Okay, Prasanjit, okay, बच्चे. What is the value of A such that the system is uncontrollable? So you can give the answer very easy because for the system is to be uncontrollable. If the system is to be uncontrollable, modulus of QC must be 0. And what is the QC matrix? Determinant. Modulus means determinant. Determinant of the QC matrix is 0 if it is uncontrollable. And what is the QC matrix? Everyone knows controllable matrix QC is B. First column and second column is AB because it is a 2 by 2 matrix. So B is given as 1 1 and A multiplied by B is the second column. So first I am calculate the QC matrix. QC matrix, controllable matrix is, as we know, B and AB. B is given as 1 1. Yes, Prasanjit, very good, bache. Correct answer. Your answer is correct. And if you multiplied with AB, if you multiplied A matrix with B matrix, what you get? 2 by 2 and 2 by 1. So 0 into 1, 0 minus 2. So if this element is 2 and 1 plus A, it is the second column. So 2, 1 plus minus 2 and 1 plus A. This is the QC matrix. And if it is uncontrollable, determinant of QC is 1 1 minus 2 1 plus A is equal to 0. So it is 1 plus A plus 2 is equal to 0. So implies A is equal to minus 3. A is equal to minus 3. A is equal to minus 3 is the correct answer. So correct answer of this question is minus 3. I hope it is clear to everyone. Now moving to the next question. If the Bode plot is given, magnitude versus frequency plot is given or asymptotic magnitude plot is given, what is the transfer function? Anyone can give the answer of this question because it is a type 0 system. Starting slope is 0 dB per decade. So what is the correct answer? Try to give the answer of this question. It is so easy. I am also solving. First of all, see the starting slope. Starting slope give the type of the system. Starting slope of the Bode plot always give the type of the system. So starting slope of the Bode plot is 0 dB per decade. And if the starting slope of the Bode plot is 0 dB per decade, this line have the slope 0 dB per decade. And if the slope of starting line is 0 dB per decade, it means it is type 0 system. It is type 0 system. Type 0 system. And if it is type 0 system, n is equal to 0. N is equal to 0. Now, at omega is equal to 1. At omega is equal to 1, change in slope 0 dB per decade to 40 dB plus 40 dB per decade. Means at omega is equal to 1, there is a two zeros. And at omega is equal to 2. At omega is equal to 2, change in slope 40 dB per decade to 20 dB per decade. So change in slope is minus 20 dB per decade. Q final slope minus initial slope. So 20 dB per decade minus 40 dB per decade means change in slope is minus 20 dB per decade. So there is a one pole. There is a one pole. So omega is equal to 1 and omega is equal to 2 are the corner frequency. As omega is equal to 1, there are two zeros because change in slope. Change in slope is uh, slope after the corner frequency minus slope before the corner frequency. So after the corner frequency omega is equal to 1, slope is 40 dB per decade. And before omega is equal to 1, slope is 0 dB per decade. So change in slope is 40 dB per decade. So there is a two zeros. If the change in slope is positive, there is a zero. If change in slope is negative, there is a pole. Okay. And n is equal to 0. And if it is a type 0 system, starting gain is 20 log k. So I can write open loop transfer function, using the Bode plot. GSHS is equal to K 1 plus S upon 1 ka whole square. This is the corner frequency of the zero upon 1 plus S upon 2. That is the correct answer. But we have to calculate the K as well. And K can be calculated using this equation. K can be calculated using this equation. Starting gain is equal to 20 log k minus 20 n log omega. And starting gain is nothing but it is the 0 dB. Starting gain is nothing but it is the 0 dB is equal to 20 log k minus 20 into 0 because n type 0 system n is equal to 0 into log omega. Whatever be the omega, if n type 0 system n is equal to 0. So 20 log k is equal to 0. If I take the anti-log on base 10, I get k is equal to 1. So k is equal to 1. If I put k is equal to 1 here, I get open loop transfer function GSHS is equal to 1, 1 plus s ka whole square upon, if I take the LCM, I get s plus 2 upon 2. So it can be written as 2 times 1 plus s ka whole square upon s plus 2. That is the correct answer. So open loop transfer function of the given Bode plot is 2 times 1 plus s ka whole square upon s plus 2. 2 times s plus 1 ka whole square upon s plus 2. D option is correct answer. D option is correct answer. So in this question, k is equal to 1. There are the two corner frequency. First corner frequency is omega 1. Second corner frequency is omega 2. Here there is a 0 and omega 2 there is a pole. Why pole? Because slope is minus 20. And there is a 2 0. Why 2 0? Because change in slope is plus 40 dB per decade. Change in slope tell us how many number of pole and zeros lie at that particular corner frequency. I hope this question is clear to all of you because it is simple question of the Bode plot, not the tough one. If anyone have the doubt and needs more explanation, I can give the more explanation. Otherwise, moving to the next question. प्रसन्नजीत जी से समथिंग सर जिस ग्राफ वाई एक्सिस से स्टार्ट होगा हम ये वाला फॉर्मूला डाल सकते हैं बच्चे दिस फॉर्मूला ये जो फॉर्मूला मैं लिखता हूँ दिस फॉर्मूला यू कैन अप्लाई टू एनी स्टार्टिंग स्लोप लाइन जो स्टार्टिंग स्लोप की लाइन है उसको उस पर ये फॉर्मूला आप अप्लाई कर सकते हैं दिस फॉर्मूला इज एप्लीकेबल फॉर स्टार्टिंग स्लोप लाइन स्टार्टिंग स्लोप की लाइन पर कहीं भी लगा सकते हैं इसे एनीवेयर on starting slope line स्टार्टिंग स्लोप लाइन पे कहीं भी लगा सकते हैं, यानी कि प्रसन्नजीत मेरा कहना यह है, ये स्टार्टिंग स्लोप की लाइन है, यू कैन अप्लाई दिस फॉर्मूला, starting gain is equal to 20 log k minus 20 n log omega here as well as here. From this to this starting slope line, you can apply anywhere, here or here. You can apply this formula, but you cannot apply this formula here because slope is changed. Once the slope is changed, you cannot apply this formula. 20 log k minus 20 n omega can be applicable only for starting slope line. You can use this formula for starting slope line. Anywhere from this point to this point, you can use anywhere the starting slope line formula. This is the important point. Here you can apply here or as well as here. Up to this, up to this you can apply anywhere starting formula. Gain is equal to starting gain is equal to 20 log k minus 20 n log omega, where omega is the frequency at that particular gain and n is equal to type of the system. I hope it is clear to everyone. Moving to the next question. Yes, this question is again the Bode plot question, but relate the compensator with the Bode plot. The Bode magnitude plot of a lag compensator is given in the figure below. You have to calculate the angular frequency at which the phase lag provided by this compensator will be maximum. So you have to calculate omega. The frequency at which maximum lag is provided by this compensator. So you have to calculate the omega f. Okay, Prasenjit, okay, bache. Try to give the answer of this question. So there are two corner frequency in this question. One is omega 1 because slope is changing. Although border plot is here like this line is not drawn. This line is also of the border plot line and it is like this. So this frequency is the omega 1 and this frequency is the omega 2. These are the two corner frequencies because corner frequencies are the frequency where slope of the border plot is changed. So these two frequencies, border plot slope is changed. At omega is equal to 2, at omega is equal to 7. And the geometric mean of the corner frequency gives the maximum phase frequency at which maximum phase angle, maximum phase lag provided. So maximum frequency is the geometric mean of the corner frequency. You must write like this. You must write like this. It is the border plot is given, magnitude versus frequency plot. And omega m, we know that the frequency at which maximum phase lag occurs, the frequency at which maximum phase lag occurs omega n is geometric mean of corner frequency omega 1 multiplied by omega 2. These omega 1 and omega 2 are called corner frequency. Corner frequency. These omega 1 and omega 2 are called corner frequency. I hope it is clear. So, what are the corner frequency? First corner frequency is 2. Second corner frequency is 7. So, correct answer is under root 14 radian per second. But in the NAT question, you have to give the answer in decimal point. So, under root 14 if I solve, I get 3.74. So, correct answer of this question is 3.74 radian per second. So the frequency, you must know the formula this. The frequency at which maximum phase angle, phase lag occurs is the geometric mean. Under root AB is called geometric mean of the AB. So this is called geometric mean of the corner frequency. This is called geometric mean of the corner frequency. Geometric mean of corner frequency. So using the border plot, you can calculate the corner frequency, and corner frequencies are very easy to calculate. The frequency at which slope of the border plot change, that is called corner frequency. So one corner frequency is omega 1 and second corner frequency is omega 2. Here slope is changing and here is also slope changing. So it is a these two corner frequency, and geometric mean of the corner frequency gives us the frequency at which maximum phase lag occurs. So it is correct answer is 3.74 radian per second. Now moving to the next question. Try to give the answer of this question. This question is related to the resonant frequency. The characteristic equation of a negative feedback system is given as 1 plus GSHS is equal to 1 plus 64 upon H into H plus 8 is equal to 0. So you have to calculate the resonant frequency omega. What is the resonant frequency? So resonant frequency formula is, if I give you the solution, resonant frequency you already know. Omega R is equal to omega m under root 1 minus 2 zeta square. What condition? This is a conditional formula. You cannot apply this formula directly. It is the omega n natural frequency. Omega n under root 1 minus 2 zeta square. But this formula is only valid if zeta is less than 1 by root 2. Because resonance only occurs if the zeta is less than 1 by root 2 or zeta is less than 0.707. If beta is less than 0.07, then this formula is valid. You cannot apply this formula blindly. You have to cross check whether zeta is less than 0.707 or not. If zeta is not less than 0.707, you cannot apply this formula. Or you can directly say resonant will not occur. Resonant will not occur. So before applying the formula, you must ensure that theta must be less than 1 by root. Now give the answer. Try to give the answer of this question. If you make the closed loop characteristic equation, of this question, closed loop characteristic equation 1 plus GSHS is equal to 0. Yes, Prasanjit is giving the answer. I am solving, Prasanjit. I think, okay, zeta is correct. Bache, zeta is correct. You have given the correct answer of zeta. So 1 plus 64 upon S into S plus 8 is equal to 0. So it is S square plus 8S plus 64 is equal to 0. If you compare with the standard characteristic equation, what is the standard characteristic equation? Yes, Ashok, your answer is correct, bache. Your answer is correct. If you compare this equation with the standard characteristic equation, S square plus 2 zeta omega ns plus omega n square is equal to 0, you get omega m n square is equal to 64 or omega n natural frequency is 8 radian per second. And 2 zeta omega n is 8. So 2 zeta is equal to 1 or zeta is equal to 0.5. And since zeta is less than 1 by root 2, so you can apply the formula directly. So what is the resonant frequency? Resonant frequency is omega n under root 1 minus 2 zeta square. Omega n is the 8 under root 1 minus 2. Zeta is 1 by 2 whole square. So you get 8 into 1 minus 2 by 4. 1 minus 1 by 2, 1 by 2, 8 by root 2. 8 by root 2 is 4 root 4 multiplied by 1.414. So it is 5.656 radian per second. So correct answer is 5.656. 4 root 2 is the correct answer. And if you put the value of root 2 1.414, you get the 5.656. So correct answer is 5.656. Up to the 2 decimal, it is 5.66. So up to 2 decimal point, it is 5.66. And if you write up to the 3 decimal point, it is 5.656. So in the gate examination, it is given up to the 2 decimal point or up to the 3 decimal point. Okay, VK is also joining 5.656. Thank you, VK. Thank you, Bache. Very good, correct answer. VK, have you joined recently or from the starting you are there? Uh, so the saying that this type of objective question where you are fine. Bache Ashok, I have 20 years of teaching experience. I have lot of resources to help you. So no problem. I have very uh, lot of questions for the practice. So daily I will take the marathon for every subject I will take. So don't worry, Ashok. I have many questions, objective questions. Okay, VK is saying, sir, I am joining late. Okay, VK, no problem, bache. Okay, moving to the next question. Try to give the answer. The open loop transfer function of a negative feedback system is given by this. The value of gain k such that the point minus 1 plus j lies on the root locus. Minus 1 plus j1 or minus 1 plus j lies on the root locus. So it is a magnitude criteria. You can directly use the magnitude criteria and give the answer. Easy, so easy question. Only give me the answer. Only give me the answer because this question is so simple. Open loop transfer function of a system is given, and at this particular value of s, this particular value of s minus 1 plus j1 per, you have to calculate the k. So you just apply the magnitude criteria because if it is an NAT question, that means directly you can assume that this point lies on the root locus. Otherwise, if one of the option is that does not exist, you have to check whether this point lies on the root locus or not by applying the angle criteria. But if it is a NAT question, so no need to check that whether this point lies on the root locus or not, because it is understood that this point lies on the root locus. Only you have to apply the magnitude criteria. So to determine the value of k, to determine the value of k, apply magnitude criteria of the root locus. Apply magnitude criteria of root locus. And if you apply the root locus, what is the magnitude criteria? Magnitude criteria is modulus of GSHS at this particular value of S is 1. So if you apply K into modulus, I am calculating the modulus at S is equal to minus 1 plus J1. So if I calculate what I get, K times 1 minus S. If I put 1 minus S, so 1 plus 1 become 2. 1 minus S. So it is 1 plus 1, 2, 2 minus J1. 1 plus S. 1 plus S is only J1. Upon, yes, Ashok is giving the answer, correct answer. Ashok, your answer is correct, bache. S square. S square is minus 1 plus J1 into minus 1 plus J1. 2 times because I have to take the modulus. No problem at all. Into S plus 3. S plus 3 means 2 plus J1. Modulus is equal to 1. So if I calculate what I get, K 2 minus J1 modulus is under root 5. J1 modulus is 1 upon minus 1 plus J1 modulus is under root 2. Minus 1 plus J1 modulus is under root 2. 2 plus J1 modulus is under root 5. Under root 5 is equal to 1. Under root 5 cancelled out. So K is equal to under root 2 multiplied by under root 2. So K is equal to 2. Very good. Prasanjit, Ashok, your answer is absolutely correct, bachcho. So K is equal to 2 is the correct answer. K is equal to 2 is the correct answer of this question. Very good, Ashok, Prasanjit. Okay, moving to the next question. Try to give the answer of this question. It is little bit tricky question. Just read the question carefully. The open loop transfer function of a unity feedback system is given. It is the open loop transfer function and it is asking the impulse response of the closed loop system. Impulse response of the system is understood it is a closed loop system. Closed loop system. So open loop transfer function of a unity feedback system is given. Means GSHS is given and you have to calculate impulse response of the closed loop system. And impulse response is nothing but it is the transfer function. Everyone knows impulse response is nothing but it is the transfer function of closed loop system. So impulse response, if I solve, impulse response is nothing but it is the closed loop transfer function. And what is the closed loop transfer function? Closed loop transfer function Ts of a unity feedback system is Gs upon 1 plus Gs. Hs is 1 because feedback is unity. Negative feedback Hs is 1. So if you put Gs value is given as 4s plus 4 upon s square. It can be written as 4 times s plus 1 upon s square. So if I solve, I get 4 into s plus 1 upon s square divided by 1 plus gs. Gs is again 4s plus 1 by s square. So if I solve, I get 4s plus 1 upon s square plus 4s plus 4. That is the closed. Now it is very easy. Once you calculate the closed loop transfer function, 4s plus 4 upon s plus 2 whole square. It can be written as 4s plus 8 minus 4 upon s plus 2 whole square. I hope you already know why I write plus 8 minus 4. Because I want to make s plus 2 in the numerator. So what is the TS? TS I got is 4 times s plus 2 minus 4 upon s plus 2 whole square. It is a simplification. So what I get? Ts is equal to 4 upon s plus 2 minus 4 upon s plus 2 whole square. If I take the inverse Laplace, I get xt is equal to, or transfer function is 4 e की power minus 2t ut minus 4 e की power minus 2t. That is the correct. You may solve by any method because I have applied this, or you may solve by any other method. So correct answer is 4 e की power minus 2t ut minus 4t e की power minus 2t ut. I hope it is clear to everyone. And the correct answer of this question is 4 e की power minus 2t minus 4t e की power minus 2t. So correct answer is the B option. If anyone have the doubt, kindly ask. So open loop transfer function of a unity feedback system is given and we have to calculate the impulse response. Impulse response means closed loop transfer function. Impulse response is nothing but it is equal to the closed loop transfer function. And closed loop transfer function is Gs upon 1 plus Gs. Okay. Moving to the next question. Try to give the answer of this question. The describing equation of the system is given by 4 d2x by dt square plus dx by dt plus 3x is equal to ft, where ft is the external force and x is the displacement in the mass. The steady state displacement corresponding to the force of 3 Newton is. It is so easy. Again, you have to apply the final value theorem. You have to take the Laplace transform and apply the final value theorem. And Ft is nothing but it is the 3 Newton. So 3 Newton force can be written as Ft is equal to 3 ut. 3 ut because constant value can be written as in terms of step signal. So indirectly 3 Newton force means you have to take Ft as 3 ut and after taking the Laplace transform using the initial condition 0, you have to apply the final value theorem to calculate the x of infinity because it is the final displacement is asking or steady state displacement is asking. So first of all, you have to put input force is equal to 3 Newton. So Ft is input force is equal to 3 Newton and 3 Newton force is 3 ut because constant value can be written in terms of step signal. And if you apply Ft is equal to 3 ut, you get 4 d2xt by dt square plus dxt by dt plus 3xt is equal to 3 ut. Taking Laplace transform both sides, it is so easy. It is a question of the time response analysis. So taking Laplace transform both sides, if you take the Laplace transform both sides, you get 4 s square times x of s plus s times x of s plus 3x of s is equal to 3 by s. Yes, Prasanjit have given the answer 1. Okay, Prasanjit, I am solving. I hope you are correct. So x of s, what is the x of s? It is 4s square plus s plus 3 is equal to 3 by s. So x of s is 3 upon s, s square plus s plus 3. 4s square, sorry. 4s square plus s plus 3. Now, if you apply b square minus 4ac is less than 0, b is greater than 0, so poles lie in the left half of the plane, you can apply the final value theorem. So, final displacement or steady state displacement, which is also called steady state displacement, we get x infinity is equal to limit s tending to 0 s times x of s. And if you solve, you are getting 1. So Prasanjit have given the correct answer x infinity as 1. Final displacement as 1. Because if you put the value, you get the answer. It is so easy. It is so easy s times o. So s cancelled out. And after putting s is equal to 0, you get the final value. Okay, I think it is the last question now. This question is the last question about the Nyquist criteria. This question is related to the Nyquist criteria and how easily you can solve this question of the Nyquist criteria. So open loop transfer function of a unity feedback system Gs is given as tan upon j omega minus 2. How many numbers of time minus 1 plus j0 will be encircled by the Nyquist flow? So some students think that this question is of the Nyquist flow. But you can directly solve this question without using the Nyquist flow. Without making the Nyquist flow, you can give the answer directly. How I am giving the answer. Solution is very interesting. Without going to the Nyquist criteria, you can give the answer very easily. So it is a open loop transfer function with unity feedback is tan upon s minus 2. K omega can be written as S minus 2. That is the answer. Question given. And if you analyze GS, one open loop pole lie in the right half of the S plane. Because if you draw the GS, one open loop pole lie at the right half of the S plane. It is the S plane. And if one pole lie in the right half of the S plane, P is equal to 1. P is equal to 1. Now, if you apply the closed loop transfer function, closed loop transfer function is your characteristic equation. Using the closed loop characteristic equation, you can see how many poles closed loop poles lie in the right half of the S plane. So 1 plus GSHS is equal to 0. So 1 plus K upon S minus 2 is equal to 0. And what is the value of K? K is 10. K is 10. K is 10. 10. So what is the answer? S minus 2 plus 10 is equal to 0. S plus 8 is equal to 0. So one closed loop pole lie in the left half of the S plane. And if one of the closed loop pole lie in the left half of the S plane, it means Z is equal to 0. Because no closed loop pole lie in the right half of the S plane. So Z is equal to 0. And once you have the Z and P, now you can apply N is equal to number of encirclement is P minus Z. Number of encirclement N is equal to P minus Z. So what is the P? P is 1. One open loop pole lies in the right half of this plane. No open loop pole lies in the right half of this plane. So number of encirclement is 1. And if N is equal to 1, it is anti-clockwise. Plus 1 shows anti-clockwise 1 encirclement. One encirclement in counterclockwise or anti-clockwise? Anti-clockwise direction. If it is asking, although in this question only asking how many times encirclement is there, but if N is positive, that means anti-clockwise or counterclockwise. Counterclockwise direction encirclement. So correct answer of this question is anti-clockwise plus 1. So B option is correct. Very good, bachcho, very good. VK has given the correct answer. Tarun has, Prasanjit has given the correct answer. Very good, smart student. Okay, bachcho. So first of all, हैप्पी न्यू ईयर इन एडवांस. कल के लिए भाई हैप्पी न्यू ईयर आप सबके लिए. और अगर स्टूडेंट को चैनल अच्छा लगता है अभी और एक्सप्लेनेशन अच्छा लगता है तो अपने साथ के फ्रेंड से कहिएगा सब्सक्राइब करें चैनल को. और अब तक मोर देन 30 वीडियोज आर ऑन द चैनल. तो आप देखें, आपको बहुत हेल्प होगी अगर आप गेट के एग्जाम के लिए प्रिपरेशन कर रहे हैं. यस यस, थैंक यू वीके, थैंक यू बच्चों. और टेलीग्राम चैनल ज्वाइन करें क्योंकि मैं उसमें भेजता रहता हूँ रिसोर्सेज. ठीक है भाई, लास्ट में यही कहना था बच्चों, शेयर करिएगा, लाइक करिएगा सेशन और चैनल सब्सक्राइब करिएगा भाई. और आप लोगों ने कर लिया है तो अपने दोस्तों से भी कहिएगा. थैंक यू तरुण, थैंक यू बच्चों, थैंक यू आप सभी को, हैप्पी न्यू ईयर. और अगले साल में हम काफी आपका जो है मैराथन लें और आप लोगों का अच्छा सिलेक्शन हो, यही ईश्वर से इच्छा है, यही आप लोगों के लिए मेरी बेस्ट विशेष है. और एक बस ये रहेगा भी, कल जो है बैकएंड टीम ने काम करने के लिए मना कर दिया है, तो कल नए साल पे कोई क्लास नहीं होगी. 2 जनवरी को क्लास लेंगे, यानी कि जो नेक्स्ट क्लास होगी वो 2 जनवरी को होगी मैराथन. कल बैकएंड टीम भाई अवेलेबल नहीं है तो कल क्लास टाइप नहीं हो पाएगी, तो इसलिए कल की क्लास लेना थोड़ा मुश्किल है. अब 2 जनवरी को होगी नेक्स्ट मैराथन और 2 जनवरी को लेंगे. कल की मैराथन नहीं ले पाएंगे क्योंकि बैकएंड टीम नहीं है, वो सब हैप्पी न्यू ईयर सेलिब्रेट कर रहे हैं. तो थैंक यू एवरीवन, थैंक यू बच्चों. वंस अगेन हैप्पी न्यू ईयर टू ऑल ऑफ यू. माय